standardisation and the 68, 95, 99.7% rule. So we're going to be having a look at that rule today and how to standardise values. So a normal distribution has the following property. This is my mean here, and one standard deviation above and one standard deviation below. This covers 68% of the values within the whole distribution. If I go 2 standard deviations above and 2 standard deviations below, so that's the green and the purple part, that contains 95% of all of the values within the distribution. And then if I go 3 standard deviations above and below, that contains 99.7% of the values. This is true for all normal distributions. So if we know that a variable is normally distributed and we know its mean and standard deviation, then we can make some useful statements about the way in which the data values are distributed. So here's an example. Here's some weights in a gym. Now, if you don't recognize this kind of machine, in order to lift the weights of your choice, there's a peg that you have to put into one of these holes, depending on which weight you want to lift. How do you think this is a representation of normal distribution? So what you can see is this lighter grey colour. That's where paint has been chipped off. So every time you try to put the peg in, you might miss the first time and hit a bit at the side. And the more times it gets hit, the more paint is going to be chipped off. So it seems that in the middle here, these weights are being used the most because they have the most paint chipped off. And then you can see that the amount of paint that's chipped off dwindles down as we go to really light weights and dwindles again as we go to really heavy weights. So lots of people are using these weights, quite a few people using these ones, not very many people up here or down here. Now, if I told you that the mean weight lifted is 27.5, this one here that has the most paint chipped away, and the standard deviation is 9, what can we say about approximate percentages of people lifting weights within 1, 2 or 3 standard deviations of the mean? Well, we can say that 68% of people will lift between 18.5 and 36.5 kilograms. 18.5 is 27.5 subtract 9, and then 36.5, 27.5 add 9. So I've taken my mean and I've subtracted 9, which is the standard deviation, and added the standard deviation to it. I can also say that 95% of people will lift between 9.5 and 45.5 kilograms. I've got 2 times the standard deviation, which is 18, and I've added and subtracted that from the mean. And also I can say that 99.7% of people will lift between 0.5 and 54.5 kilograms. Pause the video now while you have a go at questions 1 to 4 and 6 and 8. These are quite difficult to read, so if your estimates are slightly different from what's in the back of the book, that's fine. Okay, now it can be useful to convert normally distributed data into a new set of units, which shows how many standard deviations the data value lies from the mean of the distribution. The new values that you find, they're called standardized values, or sometimes referred to as Z values. To standardize a data value X, we subtract the mean of the normal random variable, and then we divide the result by the standard deviation. So our Z value is data value minus the mean divided by the standard deviation. If we end up with a positive Z value, that tells us that the data value is above the mean. And the actual value you get, that's how many standard deviations away from the mean it is. If we get a negative Z value, then the data value that it represents is below the mean. If we get a 0 Z value, the data value that we have is the mean. So now you have that, you can answer questions 10, 12 and 13. Make sure you mark your work and ask if you have any questions.